This is pre-calc final exam review 1A, problem 3. Find all the real zeros of the polynomial. This question is worded badly. Zeros are solutions. And what they've shown you here are different factorizations. But this is what the final exam is. So we have a polynomial with 1, 2, 3, 4, 5 terms. And I don't know how to factor that straight off, but I do know a rule about how to find possible factors. If I take P, which in this case is 27, and I find all of the factors of 27, which are 1, 3, 9, and 27, and I divide that by all the possible factors of Q, which is 1, I can find possible factors of that polynomial. I've got plus and minus 1, plus and minus 3, plus and minus 9, plus and minus 27. Okay, so now what I'm going to do is I'm going to use synthetic substitution. I'm going to find the coefficients of this polynomial. I've got a positive 1, a negative 2, a 6, a negative 18, and a negative 27. And I am going to plug a positive 1 in to see if I get a 0. Okay? Bring down the first one. 1 times 1 is 1. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1. 6 plus negative 1 is 5. 5 times 1. Negative 18 plus 5 is negative 13. Negative 13 times 1 is negative 13. And this is negative 40. What we're looking for is to see if this last number is a 0. And it is not, so we keep trying. So I've already tried positive 1. Now I'm going to try negative 1. I've got the same numbers for my coefficients. Okay. This time I'm putting a negative 1 on the outside. Drop the first digit. 1 times a negative 1. Negative 2 plus a negative 1. Negative 3 times negative 1. 6 plus 3. 9 times negative 1. Negative 18 plus negative 9. Negative 27 times a negative 1 is positive 27. And negative 27 plus positive 27 is 0. So this is what we're looking for. That this number was 0. We got it. That's great. That means that x equals negative 1 is one of the solutions. And what it also means is that x plus 1 is a factor. Now, the polynomial we're going to multiply with x plus 1 to get the original is going to have these coefficients. So I'm going to subtract 1 from the degree of the original polynomial. The degree of the original polynomial was 4. So this is x to the third. The next term is the x to the second term, then the x term, then the constant term. So that means that the other polynomial is x cubed minus 3x to the second plus 9x minus 27. Okay, so I'm not done. I have to factor this. I'm trying to make more room on the page. All right, so now what I want to do is I want to factor that polynomial that I got. I want to factor this, and that has 4 terms, so I'm going to do by grouping. Okay, the GCF of the first group, I'm just going to bring down the x plus 1. The GCF of the first group is x to the second. All right, x to the third divided by x to the second is x. Negative 3x to the second divided by x to the second is negative 3. The GCF of the second group is 9. 9x divided by 9 is x. Negative 27 divided by 9 is negative 3. So the stuff in the parentheses matches, the x minus 3 comes down, and then the x squared plus 9 goes in the second parentheses. X squared plus 9 is they're both perfect squares, but this is not the difference of two squares. So, right? So, go back to my multiple choices. I'm trying to make the screen bigger so that you can see my multiple choices. All right. So we're looking for, let me see if I can make the screen bigger. All right, so we're looking for which of our multiple choices is the same as my bottom line. So I've got x plus 1 times x minus 3 times x squared plus 9 is choice A.